Welcome, future IT system administrators, to this explainer. Whether you're gearing up to manage massive enterprise cloud infrastructures or you're just setting up local workstations, there is one piece of software that literally sits at the absolute center of your universe, and that's the operating system. Today, we're going to unpack the foundations of operating systems and explore how they serve as the ultimate resource managers between physical hardware and high-level applications. So, let's just dive right into it. Here's a quick look at our roadmap for today. We'll be covering 1. The OS Hotel Manager, 2. The 4 OS Pillars, 3. Matching OS to environments, 4. Windows versus Linux architecture, and finally, number 5. The IT admin's decision. All right, starting off with Section 1, the OS Hotel Manager. Now, before we actually configure any servers, we have to ask, what exactly is an operating system doing behind the scenes? Well, at its conceptual core, an OS is an active resource manager and an extended hardware abstraction layer. I mean, just imagine a world without an OS. Every single time a developer wanted to save a file, they'd have to write explicit, custom code to manipulate the low-level magnetic tracks of one specific hard drive, or manually pulse voltages to flash storage cells. It would be an absolute nightmare. So the OS handles all that terrifying complexity for us. It acts like a shield, exposing these really clean standard application programming interfaces, or APIs, to the software above it. And honestly, the best way to think about this is the hotel manager analogy. Think of your physical computer hardware, the CPU, the RAM, the hard drives, as a luxury hotel building. The guests checking in are your desktop applications, like your web browser or a video game. The operating system acts precisely as the hotel manager. The guests don't go around manually routing electricity through the walls or fighting each other over who gets which room, right? Instead, they make polite requests to the manager. The manager silently coordinates the whole shebang behind the scenes, ensuring optimal resource utilization, fairness, and of course, security. Moving right along to Section 2, the 4 OS Pillars. So now that we know the manager's role, let's take a look at their specific departments. As an IT admin, you absolutely must master 4 foundational subsystems if you want to effectively troubleshoot a machine. We call these the 4 primary pillars of OS architecture: process management, memory management, file system management, and device or I/O management. Let's break these down one by one. First up, we've got process management. A process is really just a program in active execution. Today, we totally expect to run background updates, stream our audio, and browse the web all at the exact same time. But here's the secret. A single CPU core can actually only execute one machine instruction at any given instant. So how does the OS pull off this magic trick? Well, it uses a processor scheduler to create the illusion of parallel execution. It relies on incredibly complex multitasking algorithms, like round-robin scheduling, to swap active threads on and off the CPU in literally a matter of milliseconds. It happens so fast, you don't even notice it. Next, we have memory management. RAM is essentially your system's volatile, high-speed workspace. When you've got multiple programs running, the OS has to allocate dynamic chunks of this memory to each app, while making sure they don't accidentally overwrite each other's data. And when a program closes, the OS actively clears that space out to avoid memory leaks, unless you're that person running 50 browser tabs at once, of course. Also, consider virtual memory. When your fast RAM fills up, an advanced OS will actually map a portion of your slower secondary hard drive and treat it as if it were RAM, which keeps your whole system from immediately crashing. Pretty smart, right? Okay, let's test your active understanding here with a real-world IT scenario. Imagine a user opens up a really heavy photo editing app and gets hit with this error: system out of swap space or paging file capacity. Which of our 4 OS pillars is failing in this moment? Give it a second. If you guessed memory management, you hit the nail on the head. The system has totally exhausted both its physical RAM and the virtual memory space it carved out on the hard drive. As an admin, knowing this tells you exactly where to start troubleshooting. Let's move to our 3rd pillar, file system management. To a physical hard drive, your data is just a massive, completely meaningless array of ones and zeros. The OS overlays a logical structure over those raw electronics. Think NTFS on Windows or ext4 on Linux. This layer is absolutely crucial for you as an administrator because it manages all the critical metadata. It handles the directories, the ownership rights, the hidden flags, and all those read and write permissions that you're going to spend a large part of your career configuring.
And the final pillar is device and I/O management. Computers have to talk to a wildly diverse ecosystem of third-party hardware. We're talking printers, keyboards, external graphics cards, you name it. To solve this giant compatibility nightmare, the OS provides a generic framework. Hardware manufacturers write specialized translation tools called device drivers. These drivers take standard generic OS requests, like, hey, print this document, and translate them into the specific proprietary electronic commands that the hardware actually understands.
All right, Section 3, matching OS to environments. So not all operating systems are built the same, mostly because their environments vary wildly. For instance, a consumer desktop uses a time-sharing OS. This dynamically divides processor time to keep things fair and interactive for the everyday user. But what about an enterprise domain controller? That relies on a network OS, or a NOS, which is purpose-built to host centralized user accounts and network security rules. Then you have cloud infrastructure nodes, which rely on a distributed OS to combine a bunch of autonomous physical computers into one unified system. Basically, the environment completely dictates the architecture.
Let's look at a really high-stakes scenario to put this into perspective. Say an automated commercial drone has to process sensory data and adjust its wing flaps within exactly 2 milliseconds of encountering wind shear. Which operating system type is absolutely required here? I mean, a standard time-sharing OS on your laptop operates on a best effort paradigm. If your word processor stutters for half a second, it's annoying, sure, but nobody gets hurt. That paradigm simply won't fly, literally, for a drone.
The answer here is a hard real-time operating system, or a hard RTOS. These are strictly deterministic systems. Missing a microsecond-level deadline doesn't just mean a glitch, it results in a total catastrophic failure. We're talking about things like automotive anti-lock brakes, surgical robotics, and flight controls. The timing parameters here aren't just preferences, they are rigid physical safety constraints. We also see some heavily specialized environments out there. Mobile OS platforms like Android or iOS are totally defined by strict thermal and battery limitations. They aggressively suspend inactive background apps just to manage power. On the flip side, you have embedded operating systems. These run inside appliances like your smart refrigerator or a digital washing machine. They are stripped down to the absolute bare essentials, running a single predefined loop reliably for years and years without ever needing a reboot. Let's jump into Section 4, Windows versus Linux architecture. This right here is the ultimate IT toolkit debate. To truly understand practical system administration, we have to look at the two primary families dominating modern global infrastructure. And the crucial point is understanding just how distinct their origins are. Microsoft Windows is very much the user-centric standard. It operates under a proprietary commercial license, relies on a native graphical user interface, or GUI, and handles storage using independent drive letters like C:. It's famous for its backward compatibility and its massive dominance in consumer software. Linux, on the other hand, is an open-source powerhouse. It was developed back in 1991 as a free open-source kernel. Instead of drive letters, Linux uses a unified file hierarchy starting from a single root directory represented by just a /. It favors a modular command line interface, which makes it incredibly lightweight and the absolute dominant force when it comes to enterprise backend servers and cloud environments. Now, because Linux is technically just a kernel, companies will bundle it with software managers and graphical themes to create full OS packages that we call distros. Here are 3 key flavors every IT admin should have in their toolkit. First, Ubuntu. It's the world's most popular introductory distro, which makes it perfect for transitioning Windows users thanks to its really rich graphical installer. Then there's Fedora. This is the cutting-edge incubator backed by Red Hat, heavily focused on technical innovation. And finally, we have Rocky Linux or CentOS, which offer absolute, rock-solid enterprise-grade stability that is optimized exclusively for hosting critical corporate web applications. And that brings us to Section 5, the IT admin's decision. So, we've covered the structural pillars, the diverse environments, and the architectural differences between the major players. Now it's time to put all that knowledge to work. Here is your final capstone challenge. Imagine a local school district is upgrading its computer lab. They need a system to support introductory web development students who need programming compilers and lightweight terminals. But the IT administrative staff also needs to easily apply standardized system policies. So, do you deploy Windows or do you deploy Ubuntu Linux? You have to ask yourself, how does a proprietary licensing fee per seat compare to open source freedom? How does the hardware footprint of a heavy GUI compare to a modular system? And crucially, which OS actually aligns better with the future career paths of those web development students? Think deeply about how the underlying architecture of an OS shapes not just the machine, but the entire organization relying on it. What would you choose?
Thank you so much for joining me on this explainer, and I will leave you with that puzzle to solve.